All right, we're going to get started here. This chapter, weather. Weather. There's your heading. Start a new page. If I go too fast, you can always pause the video. I'm going to cruise through this pretty quickly. Start with precipitation. I would write all of this down. Water condensing and falling as rain, snow, sleet, or hail, depending on the temperature. Precipitation is water falling from the sky in some form, and that form is going to depend on the temperature. We're going to start with rain. I would write all this down. We're going to hit the notes pretty hard today. Large drops form in the upper atmosphere. Temperatures in the upper atmosphere and near the ground are above freezing. So we have water vapor in the atmosphere. Okay, when that water vapor cools off in the upper atmosphere, it's going to condense in the form of droplets. You maybe have seen this on the outside side of your water bottle or a cup. If you have something cold in it, it's going to condense. On the outside of your toilet in the summer, the cold water inside the bowl of your toilet is going to cause your toilet to sweat or condense. Okay, well, it's the same thing. Water vapor in the atmosphere is going to get cooled off, going to condense into droplets, which are going to be too heavy for the air to hold, and they're going to fall as rain. The whole time they're falling, the temperatures are above 32 degrees Fahrenheit or 0 degrees Celsius. That is freezing in Celsius. So it's going to fall as rain. Pretty straightforward. Ooh, pretty picture. Freezing rain. Go ahead and write all this down. Rain forms in the upper atmosphere. Once again, water droplets get too heavy. They condense, get too heavy, and fall. It's cold near the surface of the earth. So cold temps cause the rain to freeze just before hitting the ground. So rain is going to fall, and then right before it hits the ground, it's going to cool off and start to freeze. Freezing rain is kind of like slushy rain, okay, where it's rain, but there's some part of it is kind of frozen, kind of slushy. So the atmosphere is warm the whole time until right before it hits the earth. Oops, thought I had a picture, maybe not. Snow. If I'm going too fast, please pause. The cold upper atmosphere causes ice pellets to form. So we have water vapor condensing and forming ice pellets because it's cold, below 32 degrees. Temperatures on the ground are very cold, causing the ice to change into snowflakes. So it starts as a small piece of ice, and then as it picks up condensation, as it's falling, okay, it's going to get even colder and cause snowflakes. So snow, it's going to be cold, cold, cold all the way down. Then we have sleet. If you're not familiar with sleet, it's like little ice pellets. They're usually kind of light. Sleet, snow forms in the upper atmosphere. As it's falling, it warms up and starts to melt, and then it refreezes. So it's cold, then it warms up, and then it's cold again. Okay, so cold, 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 then we get a little warm spot, and then it gets cold again. Lastly, hail. This is going to happen in warm weather. Okay, raindrops form in the upper atmosphere. As they fall, they hit cold layers and freeze. So we have droplets in the upper atmosphere, and as they fall, they're going to freeze into little ice chips. Okay? Updrafts are going to send ice back up where they pick up more droplets. So we have rain that's going to fall, it's going to freeze. There is updrafts in the atmosphere that are going to push the water droplets or the ice chips up in the air further, okay, where they're going to get condensation, little water droplets on them. They're going to fall and they're going to refreeze again. And they're going to gradually get bigger and bigger with the more updrafts we get. So drops fall and refreeze until they are heavy enough to fall to the ground. So we have rain falling, they're going to hit a cold level and freeze. Then an updraft, which is basically air, is going to push it back up, where it's going to gather more water, freeze, get pushed up, gather water, freeze, until it gets so big where the air can't hold it anymore and it's going to fall. The more times it does this, the bigger the hail. So if you have like baseball-sized hail, this happened a bunch of times. If it's just little pea-sized hail, maybe it only happened once. If you've ever looked at hail and looked closely, you can actually see the different layers of hail or of ice that has frozen. I thought this was kind of cool. The different sizes of hail here. Some of them you've heard of, maybe like golf ball size hail, ping pong size hail, baseball. These ones down here are pretty rare. They have softball size hail, that's pretty rare. Most of the time it's super small stuff. We will stop there for today. The world record for the largest recorded hailstone actually is in Vivian, South Dakota. I want to say about 10 years ago, 2010, 11, somewhere in there. The biggest hailstorm ever recorded. I thought that was kind of cool. South Dakota's claim to fame. That is our notes.